But dear students, today we'll see what do we mean by clamper circuits. Now, a clamper circuits come under the topic of wave shaping circuits. Now, a basic clamper circuit is a circuit which changes the DC level of a waveform but does not affect its shape. Okay, so it consists of basic elements like a capacitor, diode, and resistor. There are two types of basic clampers. They are positive voltage clamper and negative voltage clamper. So let's start with the topic, what is clampers? Then we'll see first what do you mean by clamper. As I've told you earlier, a clamper circuit can be defined as a circuit that consists of a diode, a resistor, and a capacitor. Okay, a diode means you should have a knowledge of how do we forward bias and what happens in forward biasing of a diode, and how do we reverse bias and what happens when the diode is reverse biased. Then you are having a resistor and a capacitor which can store a charge and discharge. Now this circuit, which consists of diode, resistor, and capacitor, can shift the waveform's DC level without changing the actual shape of the waveform. Okay, therefore a clamper circuit is a circuit that adds a DC level to an AC signal. Now, if you go to see the types, basically there are two types of clamper circuits. They are positive clamper and negative clamper. First, we'll start with positive clamper. So here you can see a circuit of positive clamper. Okay, so here you see the input waveform. This is the input waveform. What you're going to give here, it's been shown here, input. Then you are having a capacitor in series here, and then you are having across that a diode connected in this way, and then there is a resistor across which the output voltage is taken. Now input voltage, you see that it is having positive half cycle and negative half cycle, and the center line here, this comes at the 0. So this is your this is your DC line. Okay, so 0 upon 0 you are having positive half cycle and negative half cycle. So let's start with the explanation with negative half cycle. So say when the input is negative half cycle, this is your input, negative half cycle. At that time, we see when the input is given as negative half cycle, the capacitor will charge with a polarity minus plus in this way. A capacitor will charge with a polarity minus plus. Okay. So when this input is negative half cycle, that means your diode will be minus plus. So it will be forward bias. It is going to conduct. Okay, it is going to conduct, and the output voltage will be 0, and the capacitor will get charged with minus plus polarity. This is your capacitor voltage, okay, which will be equal to our input voltage only. The full voltage will come across the capacitor. Similarly, when the input becomes positive half cycle, when the input becomes positive half cycle, okay. So here we saw that when the input was negative half cycle, the output voltage was 0. So when the input was negative half cycle, the output voltage was 0. So here you can see it is 0 here. This is when the input is negative half cycle. Okay. Now when the input is positive half cycle, when you see as the input is positive half cycle, then at that time what happens? When the input is positive half cycle, we see that this is positive and this is negative. So if you apply this to the diode will be reverse bias. So there will be no current flowing through this, and the voltage input will come in series with the capacitor voltage. So the output voltage at the output here will be a combination or the summation of the input voltage plus capacitor voltage. Now a capacitor voltage will be as same as the input voltage in the earlier case. So this will be twice the input voltage. Output will be twice the input voltage. So when the input is positive half cycle, output you can see here it is twice the input voltage. So the input voltage was Vm and then it has gone to 2 Vm. So this full cycle, the full cycle positive and negative, what you have seen here is shifted on top. You are having positive and negative half cycle here. So it has gone to positive side and it is called as a positive clamper. Okay. Now you can change this waveform either from here, you can bring this waveform little down, you can get this waveform little up. You can do these things if you apply a voltage source here. If you apply voltage source here, either positive voltage or negative voltage, anything you can apply, and that will be called as positive biased clampers. Okay. So here, positive clamper circuit is one that consists of a diode, a resistor, and a capacitor, and that shifts the output signal to the positive portion of the input signal. And then we'll go to see what is negative clamper. Now, when we see negative clamper, again you are seeing the input over here. So input is applied here, and you see that the capacitor is in series. The diode is in position, which is reverse to that of positive clamper, and then you are having a resistance, and here you are going to take the output voltage. Now here the input is given as positive and negative half cycles, and the center line is your 0 DC level, and output we should see that the output comes to the negative side. Okay, now here in the figure, when the input is positive, okay, when the input is positive, the diode is forward biased. So this is positive, the diode is forward biased, and it will conduct, it is going to conduct, and in that case the voltage across the capacitor which will charge will be plus minus. This will be your voltage across the capacitor, and in that case, because the diode is conducting, there is low resistance and the output voltage is 0. So when the input is positive half cycle, okay, so when the input is positive half cycle, here the output is 0. Output is 0. Okay. Similarly, when the input is negative half cycle, when the input is negative half cycle, this is minus, this is plus. So if you apply this to the diode will become reverse bias. It is not going to conduct, and this voltage will come across or along with the capacitor voltage that is in series. So V in will be series in VC, and the output voltage will be the sum of V in plus Vc. Okay, and both are negative voltages, so it will become minus 2V in. Okay, so V naught will be equal to minus 2V in, and you come to a point here where it is minus double time on the negative portion. Okay, now this will be called as a negative clampmeter. You are shifting the DC level. This is the DC level from 0 to this. Okay, so it is negative clamping. You can also have this output voltage like this, or you can also have this output voltage like this with respect to the DC line here, and that can happen if you put a voltage here. So here if you take a voltage in this portion, if you can put a positive bias or you can put a negative bias, and it can be called as a negative biased clamping. Okay, and in that way the desired DC level shifting you can do. Okay, so this is what how you do a negative clamp. A negative clamper circuit is one that consists of a diode, a resistor, and a capacitor, and that shifts the output signal to the negative portion of the input signal. If you go to see the applications of clampers, it can be used as direct current restorers. It can be used as which can remove distortions. It can be used as voltage multipliers. It can be used for the protection of amplifiers. It can be used as test equipment, and it can be used as baseline stabilizer. So these are the few applications what we can mention for clampers. Thank you, students.